Good morning. This lesson is for my Honors Integrated 1 class and my Integrated 1 class. But before I get started, I want to say that I hope that everyone is doing all right out there. This is a second part in a two-part video lesson. I don't know what the title is, but what I do know are our two goals today. Our first goal is going to be an introduction to the structure of a two-column proof, and our second goal is going to be to walk through a few examples of two-column proofs. Let me tell you this right off the bat. You're learning new math. You're going to struggle. It's totally understandable. All right? The more vocabulary you know, the better off you're going to be. The more familiar you are with recognizing shapes, the better off you're going to be. But you're going to struggle a little bit. It's okay. You're learning something new. That's what happens when we learn something new. So let's continue. So a two-column proof will be in the following format. You will be given something. You'll be asked to prove that given turns into what you're trying to prove, and sometimes it involves a picture. This is the two-column part of the two-column proof. On the left side, you have your statements. On the right side, you have your reasons. You will be given a starting statement, and you will need to construct a logical and sequential argument that results in what you are trying to prove. It is very helpful to spend some time listing all that you know about the given and the proof. Hopefully you will see how to connect the two. You can also get clues from the picture that is associated with the proof. In college I was a pure math major, and I had to take a computer programming class, C++, and I thought, why do I have to take this class? Well, because the same skill set that you need to do a mathematical proof is the same skill set you need to do a computer program. So for those of you who are interested in programming, this is really good practice for you. All right, back to the two-column proof structure. Right, we've got our given, whatever, we're going to prove that it's that, and we have our picture. The statement. These are the claims that you make based on definitions, postulates, properties, pictures, theorems, etc. that lead to what you're trying to prove. On the reason side, these are your justifications that support your claims. So I'm going to erase all of this. I need to talk a little bit more about the first goal, and then we're going to talk a little bit, we will talk about the second goal. So let me clean this up and I'll be back. I'm back. Let's go ahead and finish our first goal here. And I just wanted to end the first goal with how we start every single two-column proof. So the first statement in a two-column proof is always what is given. And the reason is always given. So we get the first step. Always, always, always. So I have here our second goal, and I'm going to walk through a few examples of two-column proofs and just get you to see kind of how to do this. Now again, I need you to keep in mind, this is not easy to learn how to do. Now you'll start to see as I require you how to do two-column proofs, we're only going to focus on one style of argument. And it's actually what we'll see here in this proof. So we'll see this type of proof, which I'll elaborate on in a minute. The second example is a proof that I'll walk through it with you. I don't expect you to learn that style quite yet, but I do have a lot of success with my students when we learn how to do a proof in a particular style. So this proof is actually the style of proof that we're going to be using a lot for the first, couple of weeks that we learn how to do proofs. And then once you get comfortable with this, we start to see variations of it, and then we move on from there. All right, so we're given here that triangle ABC is congruent to triangle RST, and that angle R is congruent to angle T. I would like to prove that angle T is congruent to angle A, and I have a picture of my two triangles which are congruent. All right, so let's use the end of our first goal. The first statement is always what is given to us, and our reason we can say that is it's always given. So I'm going to put a 1 here, and I'm going to say that triangle ABC is congruent to triangle RST. Email. And I'm also going to include the fact that angle R is congruent to angle T, and I can say this because it was given to me. So we can do this without really doing any thinking about what we're dealing with, or trying to connect the end to the beginning or the beginning to the end, build a bridge. So I have off to the side a little place to do some observations about the given, and then I have a little bit of space off to the side to do some observations about what we're trying to prove. So let's go ahead and look at our first clue. Right, our first clue is triangle ABC is congruent to triangle RST. Well, I hope that you recognize what this was or is from our previous lesson. This is a congruence statement. We have a congruence statement. And when I have a congruence statement, the clue that I'm given without saying it directly is I know that the corresponding parts must be congruent, so I'm going to list those. I know that angle A is congruent to angle R. I know that angle B is congruent to angle S. I know that angle C is congruent to angle T. I also know that side AB is congruent to side RS. I know that side BC is congruent to side ST. And I also know that side CA is congruent to side TR. Okay? This was my clue from this part of the given. We were given that. I also know that angle R is congruent to angle T. Angle R is congruent to angle T. That's my second clue. This is all that I know from what was given to me. Now, my prove notes, I don't really have much. I know that I want to get to the point where angle T is congruent to angle A. Right? Let me make sure that I'm on the screen here. Oh, I'm okay. By a mile. Okay. So I want to get angle T and angle A together. I know all of these facts about what I'm starting with for my clue. And so I'm just going to focus on wherever I see an angle T or an angle A over here. Right? Oh, I got something about a T and an angle R. Okay, that's useful. And I got something about an angle T and an angle C. Okay. And I got something about an angle A and an angle R. And you know what? This looks like the transitive property. This looks like the transitive property. So I'm beginning to understand the structure of my argument, right? I see that I can say that angle A is congruent to angle R because they are corresponding parts of congruent triangles. And when I say that, I now have two angles congruent to a third angle, which will mean that the two angles must be congruent, and I can complete my argument. So I don't need to say everything, I just need to say what's useful. Right? A lot of this is like extra information. Alright, so my second statement in my argument is going to be that I can say that angle A is congruent to angle R. And this is true because the corresponding parts of congruent figures are congruent. Okay, so I have that. And again, I've created a situation where I can use a transitive property. Now, if well, we'll do this a little bit more accurate than, well, yeah, we'll do this. Okay. So I could, now I could use what's called the symmetric property if I wanted to. You know, we're not going to do that. Yeah, we will. I talked myself out of it and then I talked myself into it. I could also now say that angle T is congruent to angle R, and I can switch the order because of the symmetric property, right? And this last step is going to be the argument style that we're going to be using a lot, and we'll see it over and over and over again, and hopefully it begins to make sense to you. If two things are congruent to a third thing, those two things must be congruent, and I want it in that order. So I can say angle T is congruent to angle A, and I can say that because I used the transitive property. So again, I know what my first statement's going to be, and I know the reason why. I find clues about my given statement. I didn't really get much of what I'm trying to prove. I didn't use a picture in this example, but maybe I need to the next time, right? And I want to encourage you guys that this is going to take some practice. This is not something that you're going to be good at right away. And another thing, in your homework, you're going to see it written like this. Maybe you'll have a blank there, and then maybe you'll have a blank there, and you need to figure out what goes there, and maybe another blank. So let me erase this. I'll do another example of a proof because I said I was going to do a few examples. So again, let me clean this up, and I'll be back. I'm back. Let's go ahead and continue with our second goal, which is walking through a few examples of two-column proofs. Again, I have my two-column structure. I know what's given to me, what I'm trying to prove. Here's a picture that represents it. I'm going to go ahead and write down my first statement and my first reason because those are easiest to do. Nobody should miss these. So given to us is that triangle ABC is congruent to triangle DBC. And I can make this statement. I know it's true because that's what was given. Right? So we should always be able to write the first statement and the first reason. So now let's jump over to our given notes. Hopefully you recognize what we're starting off with again. We're starting off with a congruence statement. And it's let's see where this leads us. So triangle ABC is congruent to triangle DBC, right? And again, I would know that angle A is congruent to angle D, and angle B is congruent to angle B. This is not written correctly. It should be, because if I say angle B, I'm not being very specific. It should be ABC. So angle ABC is congruent to angle DBC. And I can't just say angle C because it's not very specific, just like it wasn't for angle B. So I'd have to say angle BCA is congruent to angle BCD. Let me learn my letters here. So those are the congruent corresponding angles. Let's write down the congruent corresponding sides. I know that side AB is going to be congruent to side DB. I know that side BC is going to be congruent to side BC. A little bit of reflection going on here, right? And I know that side CA, wrapping around, is congruent to side CD. Okay. All right. So I don't think I can go any farther with my given notes. I can only write out the congruent corresponding parts. But my proof notes, point B is a midpoint. What does it mean to be a midpoint? And I hope you understand what I'm doing here. I'm digging into the clues. 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 If I find how these clues can be connected, then I can bridge what I'm starting with to what I'm trying to get to, and I can start to figure out how to combine them and make my logical sequential argument. And again, it takes practice. Realize that I've been looking at these definitions and working with these things longer than you've been alive. So to me, it's like, oh, okay, I see right away. But for you guys, you know, these steps I think would be very, very helpful. So a midpoint. All right, well, what does it mean to be a midpoint? Well, midpoints cut segments into two equal or congruent parts. And what segment am I looking at specifically? I'm looking at segment AD. So am I able to determine if AD was in fact cut into two equal parts specifically at point B? The camera's there, not over there. So let's see. Let's see if I've got anything where I start with, because I know where I want to end and maybe I can bridge it. Do I know anywhere that AB is congruent to DB? Yeah, I do. I know that. I know it's true because it was part of the congruence statement. So I now just need to articulate that these are the same, and then cut it in half at point B, and then I can reach my conclusion that in fact point B is the midpoint. Now, here's where I'm going to differ with other math teachers when it comes to doing a proof. And here's why. Other math teachers just say, tell me the definition, or tell me the postulate number, or tell me the theorem number. I don't remember the theorem numbers because in every book I've taught out of, they're different. And I'm not going to waste my time memorizing what this book says or what this book says. And besides that, you can do this and get the right one. What I am interested in you is articulating what your reason is. Okay, so that transcends any math book that I teach out of. So again, let me walk you through the argument that I'm going to have here. I can say these are the same, which means this got cut in half, which means that that's a midpoint, and I'm done. Right? So I know that segment, and I don't need all this. I'm only interested in segment AB being congruent to segment DB. AB being congruent. And this is true, again, because corresponding parts of congruent figures are congruent. All right? Which means segment AD got cut in half at point B. So let's see here. How do I articulate this? And I know that segment AD got cut in half at point B because segment AB and segment DB make up segment AD. We can say it like the addition. Segment AB plus segment DB, they add up to. Well, no, I'm not saying that right, am I? So segment AD is cut in half. See, I'm having a little bit of trouble in this. You know, here I am a teacher, so I just said I didn't have trouble. So segment AD is cut half at point B. This is true because these segments are equal, right? Because segment AB is congruent to segment DB. You know, and again, it's hard to articulate. It takes practice, you know. All right, so because I was able to say that my segment was cut into two congruent equal parts, I can now conclude that point B is the midpoint. And again, this is going to take practice, guys. And I know that it's the midpoint because that's the definition of what it means to be a midpoint, right? I might have gone a little too in-depth on this example, but that's okay. I don't want you to see this, but this is not going to be the argument style we're going to be focusing on. We're going to be focusing on the transitive argument style. So it's going to take some practice. Hang in there. Remember, use your clues. See how to bridge them together. It's got to be in there. It's got to be in there somewhere. So make sure you understand vocabulary. All right, that's going to be a big, big part. The more you have, the better it's going to be, or the easier it's going to be. So I'm going to go ahead and end this lesson here. Again, I hope everybody is doing all right out there. Have a good day, everybody. Bye-bye.